And finally, we can test our model to see the efficiency, whether the model performed good or not. So double click on that and let me write a try catch. And here we can show a message, error message in case of an error. So to test the model, first we make sure that x_test, our test data, is not null, or its labels also, y_test is equals null. Then in that case, we can throw a new exception. No test data was found. Okay. If we have some data, then we can go ahead and test it. So I want to store both the predicted labels as well as the actual labels somewhere in a list. So when I will pass those to the ANN will give me a prediction. And also I have already the label stored in y_test. So let me go and store it in another list for easiness. For example, integer, and I can call them predicted label. Initially we set it to null, and also list of integers actual label is equal to null. And we can create objects for those. Predicted label is equal to new predicted label, and actual label is equal to new actual labels object. Okay, now we need to loop through all the data in our x_test, pass it one by one to the ANN model that has been trained, and then we can get the predictions. And one more thing is very important: our ANN should not be null. If it is equals to null, still we should throw an exception, or trained ANN was found, let's say. So now loop through all the test data, x_test dot rows, and we can use ANN.predict method, and from x_test dot get row, so we will get one row at a time. So ith row, and it will give us a prediction. So this will return us a float number. We can, though, since it is giving us the, what we call it, the, so this one is giving us a float number, so let us take it into another variable called prediction, and we can add this prediction into our predicted label dot add, and we need to convert it into an integer, so I'm going to cast it into an int. So we just added the predicted label into our this predicted label list, and what was the actual label, so that we can compare it and get the result. So the actual label is basically stored in y_test at ith location and 0th row, so column, sorry. Hence it should be dot add. Okay, so actual label, so we added the predicted label for that instance for the test, and we also read the actual label, so that I will compare these two values for evaluation later. Okay, so we have the predicted labels as well as the actual labels. It is time for evaluation. So for evaluation, we can basically create a confusion matrix, and from confusion matrix we will do some metric calculations such as precision, recall, and accuracy. So first, let's go and create a confusion matrix. And to create a confusion matrix, we can easily create a function in this helper method. So I'm going to add one more method here, public static, and it will return a two-dimensional array of confusion matrix. So we can say compute confusion matrix, and we need to pass the array of integer array of actual values and an integer array of predicted values. And here first we need to get what is actually, and let me write a try case before writing anything. Okay, so throw new exception if there is any exception, and we can get the number of classes by passing the actual value. So we can do that by calling, for example, number of classes that we have in these actual values. So we can say actual dot distinct dot count. So this one will give us unique number of labels, that is the number of classes that we have, and then based on that we can construct a two-dimensional confusion matrix. So I call it CM is equal to new confusion matrix, and of course its size will be the same as the number of classes times number of classes. So that's it. We just created a confusion matrix, and now we need to fill it. And one also thing that we need to make sure that the length of these two should be same. So if it is not, then we don't have to process it. So if actual dot length is not equal to predicted dot length, then we can throw an exception. Throw new exception, and we can write something vectors lengths not match. And I think this should be the first thing that we should do in this method. If both are not same, then we cannot process it. And then we can construct the confusion matrix. Let's say for I is equal to 0 to actual I is less than actual dot length. And first we calculate the indexes based on those classes. So let's say integer x is equal to predicted. What is the value of the prediction, let's say, and also the y is equal to, I can say, the row and a column is equal to actual dot I. So we get the index 0 or 1 in this case, and then we can increment these CMs of row comma column. Sorry, it should be like this. Whatever the value that we have, we are going to increment it. If both are same, so we are increasing the diagonal value. If any of them is different, so we are increasing the value for the wrong class. It means that it is not classified correctly. So this one will give us an idea that what we have or what we have achieved so far, and we can then return this CM. Okay, and we can also do something using this confusion matrix, and we will try to make all the diagonal elements to be as maximum as possible. So the diagonal elements will have the correct classification. And we can also calculate the accuracy, precision, and recall. So I'm going to create another method, static, and let's say we want to return a double array consisting of these three values and calculate matrix. We need to provide a two-dimensional disconfusion matrix. And what were the actual values? Do we need them? Let's say we can pass them, but we may not need them. But let's say that we also pass these values. And let me write a try catch first. New exception ex.message. Okay. What we will do here is let's create a double array and we call the matrix is equal to new double, and we are going to return three values. If you have more than that, you can also return those values. For this scenario, I'm just going to calculate accuracy, precision, and recall. Before completing it, I also need other two or three methods to get the diagonal elements of the confusion matrix, get the sum of the columns and the sum of the rows. So let me first write those methods, and I need to use them here. So public static int, so this one will be for getting the diagonal elements of the confusion matrix. Diagonal, and we need to pass the confusion matrix. So matrix, let's say, and I will be using the link technique to return the diagonal elements. So I'm just making it very short and flexible. Enumerable dot range, it will start from 0, and a matrix dot get length in the first dimension, that is the number of rows, and then we can use a select I matrix of I comma I, and convert it into an array. That's it. So this one will give us all the diagonal elements of our confusion matrix that we will pass into it. Also, I need to write a method to get the sum of the columns and the sum of the rows. So I'm going to use this method and I call it get sum of columns, and we need to pass again the matrix, the confusion matrix. I call it matrix, and first we need to get the number of rows. Matrix dot get length in the first dimension, that is the number of rows, and also the number of columns should be matrix dot get length in the second dimension, that the number of columns that we have. And then we can now create an integer array to keep the sum of all these values, and a column of sum is equal to new int, and its size should be same as the rows that we have. So all of both are same, but let's say the columns, because we are going to take the sum of the columns, and now we can loop through each row and column. So column into column is less than columns, and again for each row in rows. Then we need to do column sum of column plus equals to whatever the value we have in the matrix of row comma column. So this is, we are looping through all the rows. It means that we are taking the sum of each column here, and then we write it in this array, and we do it for all the columns. And once we do that, now it's time to return the column sum. So this one will essentially generate the sum of the columns, and we also need to calculate the sum of rows. So static, it will be the same except few things. Get sum of rows, and this one is also getting integer matrix. So this is the confusion matrix that we will receive. Maybe I will copy most of the things from here, and for the sake of clarity I just rename it to be row sum, and let's rename all of it. And instead of going columns, we need to go by rows. So just I update the loop like this. So for each row we are taking the sum of all the columns, and here we need to change it to be row, and that's it. So this one will go through all the columns and calculate the sum for the row, and we return it. So the methods for receiving the sum of the rows and the sum of the columns and also getting the diagonal elements is ready. So let's go and use it. Now we can create the confusion matrix. CM is equal to helper function or helper class dot compute confusion matrix, and this one is expecting the actual labels dot to array because it is expecting an integer array, and a predicted label dot to array, and this one will calculate a confusion matrix for us and return it. And also we can now calculate the matrix or whatever we have calculated. Three matrices have been calculated, and by the way, did I calculate it? No, I think. Okay. It is not completed, so I need to complete it. So let us call this method variable matrix is equal to helper class dot calculate matrix, and this one is expecting CM and the actual label dot to array. I don't think we used it. I don't know. Somehow let's send them predicted label dot to array. What this one is saying, convert to integer. And did we create an integer array? So we need to do something like this. So let's complete the calculate matrix method, and we need to calculate the number of samples that we have is actual dot length. So this is the number of samples in our test data, and classes we have is equal to cm dot get long length 0. It means that we have the number of classes we can obtain from directly confusion matrix, and we need first the diagonal elements. Now is equal to, we can use this get diagonal method of, and we need to pass this cm. So this matrix will return us, we need to calculate the sum of these diagonal elements, so we can call it diagonal sum, diagonal dot sum. So this one will calculate sum of all these elements that we obtained in the diagonal. Okay, and we need the sum of all those column total is equal to get sum of columns for CM, and we also need the sum of each row total is equal to get sum of rows for this matrix. Okay, so once we get the sum of the diagonal elements and we get the sum of all the columns and the sum of all the rows for each row and each column, then we can calculate the accuracy. See, we can create accuracy is equal to diagonal sum, so all the elements and that we correctly classified divided by, let me convert it into a double so we shouldn't have any problem, the samples, total number of samples divided by correctly classified samples divided by total samples will be our accuracy. And we can also do the precision. For example, for precision, we need to calculate precision for all the classes, and we can then take the average of this precision also. So precision is equal to new double number of classes we have. Okay, so this is for each class. Let's run a loop. For I is equal to how many do we have? Precision.length, or the number of classes. We can calculate the precision for each class like this. Precision I is equal to diagonal, each element in the diagonal. If this one equals 0, we need to make sure. Then we say that it is 0. Otherwise, what we will do, diagonal of I divided by column total for that particular column. Okay, and to make sure that it is a double, I need to convert it into a double so that we shouldn't have any issues. Okay, it's not predicted, it should be precision. Okay, so we calculated the precision for each class by summing all the getting the diagonal element, or I mean the it's correctly classified for a particular class divided by all the sum of all the columns for that particular class. And we can also do the same thing for accuracy, sorry, for recall. So here we can call it recall, and now we can do the same thing, and instead of doing this column sum, we need to take the row total. So once we calculated the accuracy, precision, and a recall, we can put them in this matrix and return it. So matrix of 0 is equal to accuracy, matrix of 1 is equal to precision. So second is the precision I am putting here, and a matrix in third position is equal to recall. By the way, and since a prediction, sorry, it's not precision, and since it is an array, I'm interested in average, for example, for all these three classes. So let's take the average and I'll put it there. If you need the whole array, then you might need to return a list of objects. So you can change it according to your needs. And then finally, I return this matrix. And all the difficult thing it will do, just I need to call this calculate matrix, and I'm getting this matrix. We can calculate the confusion matrix and then calculate the accuracy and the prediction, and we can display it. So to display, for example, I create a text string.format. Let's say test samples. How many test samples we have? We can display them here and then put a new line plus continue. Sorry, it should be 0. The first thing should be 0, and next thing that we want is the accuracy is equal to 1, and I just want this one to be 2 decimal points are enough. \n means that next line, and precision is equal to, this is we are going to show again 0.000 and percentage, and in next line we also want to show, we don't need to put a comma here because it's \n, and then we can show recall on third position and 0.00 percentage, and now we can provide the values for it. Matrix 0, and no, the first thing is the actual label.count. Okay, let me put the values in next line, and we can multiply it by 100 just to show the percentage. Matrix of 1 multiplied by 100, and a matrix 2 multiplied by 100, and that's it. And I want to show this text in the label. Status.text is equal to text. Let's run it and see if it is working or not. So first start with the loading of the data. Okay, the status is changed, and a test train split, it is done. The next thing is train the model. Okay, with the default parameters I am going to apply. So now it shows that it is busy, it means it is Okay, the model is quickly trained, the data is too small. Okay, and now let's test the model. Okay, so this one says that there were 153 samples, accuracy is 64%, and precision average is 50%, and recall is 32%. So, I mean, it's not a bad start, although the precision and accuracy looks quite low. So this is, now we have the flexibility, we can play around. For example, if I change into rpro, and now if I trained the model, and then I test it, so you can see that the accuracy is 72.55. It has increased. So we really need to do a grid search. I mean, we need to find which values will be better. For example, if I further reduce the momentum to 5, and if I increase the number of hidden layers, so comma 50, now we have two hidden layers, and each layer consists of 50 neurons. Now if I apply, and the model, it says it is trained, and then I'm going to test the model, little bit reduced. So the most important thing is these parameters must be optimal. In practical applications, when we are optimizing the model, we need to perform a grid search on which of these parameters will produce us the optimal results, which of course I will not be doing in this project. And one last thing that I will also show in this series of these videos is how can we display the confusion matrix and see which classes have the highest problem or what classes have been misclassified. So in next video, I will show you how we can display the confusion matrix.